Good morning, good afternoon, and good evening, wherever you are connecting from. Greetings to you all from Dubai, United Arab Emirates. My name is Basit Ashaba. I am the editor for Utilities Middle East magazine based in Dubai. I would like to take this opportunity to welcome you to the first ever Utilities Middle East Power Week event. I would also like to take this opportunity to thank all our sponsors, ABB, Huawei, Jinko Solar, GE, Moxa, Wärtsilä, Heriot-Watt University, Dubai, and Mitsubishi Power. So just to give you a bit of a background to this event, despite ongoing investments in new power generation capacities in the Middle East, factors such as population growth, urbanization, and industrialization continue to drive up demand for electric power. To meet this demand, the region will require an investment of $8 billion for the addition of 62 gigawatts of generating capacity and another $50 billion for transmission and distribution over the next 5 years. At the same time, countries in the Middle East are in a race to meet their renewable energy and energy efficiency targets to ramp up the region's energy transition. So, over the next 2 days, we will hear from different panels of high-profile executives and analysts who will be sharing their insights on how utilities in the region can fully harness their natural resources, latest innovations, and capital to guarantee sustainable access to electric power. Our panel discussion will be on digitalization and the transformation of the energy value chain. This will be followed by another panel discussion in the afternoon on accelerating renewable energy adoption in the Middle East. Then tomorrow, we will have another panel session to discuss the future of gas in the region's energy transition. Our final panel session will be tomorrow afternoon, where we will discuss best ways of embracing hydrogen to accelerate clean energy. More information about the agenda and speakers for the next 2 days can be found on our website, www.utilitiesme.com. So, our topic for discussion this morning, as earlier stated, is digitalization and the transformation of the energy value chain. Today's market conditions continue to put more pressure on utilities to manage their costs and remain competitive. Traditional business models are being eroded as utilities adopt emerging technologies to optimize the flow of information, improve asset performance, increase energy efficiency, and guarantee output. Our discussion will revolve around the state of digitalization in the region's utilities sector and how to leverage the full value of technology advancements in order to overcome operational challenges. To discuss this important topic, I am joined on this panel by a team of eminent industry professionals who represent organizations that are at the cutting edge of smart technology integration in the Middle East. On this panel, we have Andre Temporiti, Head of Digital for Electrification Business Area at ABB. Hi, Andre. Welcome to the panel.
Hello, everyone.
Yes. We are also joined by Sandeep Prabhakar, Product Marketing Manager at Moxa. Welcome to the panel, Sandeep.
Thank you. Welcome, everybody.
We also have Solias Adomaitis, partner at Ernst & Young. Hi, Solias. Welcome to the panel. And lastly, we have Pierre Samatis, Senior Advisor at Roland Berger. Hi, Pierre, and thank you for joining us.
Hello, everyone. Glad to be here with you.
Yes. Well, so today Many countries in the region have placed digitalization at the heart of their energy transition plans. Where do you see the unique potential of digitalization in delivering the desired energy transition in the region? And starting with you, Andre, what advancements are you already seeing in this space?
Well, that's an interesting question. I think that we are in front of a sort of push and pull effect. While we are seeing governments pushing more for some more sustainability to transit from our current state to a new way of consuming energy, we see that the digitalization is playing an extremely important role. I think is really on the core of this shift. First of all, because we have to take in consideration that this transition will need a lot of information about energy consumption and generation that need to be analyzed and with a very very fast way. So smart metering generating a lot of data are for sure the first step to understand what is the behavior of our current consumption and how we can optimize this to go and to enter in this transition in this transition journey. The second is reducing cost. You said one of the challenges that we have is increasing complexity, increasing of energy demand, but we also have to reduce costs. So how we can do this? The answer, I think, is again with digitalization, where we can use data to enter in a more profitable way to, for instance, maintain our assets, and how this can be also extended to the concept of optimizing generation and consumption. And we will touch later maybe, but the concept of the changing the value chain is extremely important. So we have to take the consumer, put this in the middle of our value chain, and understand how this consumer can play an important role. And so how digitalization can help us to engage consumer in a different way in this journey, in this transition. Then for sure we have other vectors like electrical mobility that is also increasing a lot of the loads of our infrastructure and generating eventually other demand in terms of energy. And we have the important topic on the integration of the renewable, which again can only be achieved if we have the right understanding on how to use the data to decide where to balance the profile of the generation with the profile of the consumption. So I would say that digitalization is the tool to enter in this transition from my point of view. And this is how us in ABB are supporting customers to enter in this transition by giving the right tools for digitalizing operation and at the same time reducing maintenance costs. Things like predictive maintenance can dramatically reduce the cost of maintaining assets in the field.
Thank you. Thank you very much, Andre, for that submission. It's interesting to see how companies are becoming more customer-centric while applying digital solutions. So I'll head next to you, Sandeep. What advancements are you seeing in the digital space, and what potential do you see in utilities?
Right. Thanks for the question. As Andrea talked about, right? So digitalization or getting more data from the field requires that sort of a infrastructure which is needed to get more data. So he also touched upon topics like predictive maintenance or preventive maintenance, right? So you can only do that if you are able to collect the data from the field, right? So as Muxa, what we are seeing and what we provide is the connectivity solutions from systems like if you look at the power systems, not every power system would probably be a new system, right? Some of these systems might be old ones which are needing an upgrade, or you will need to get the data from old legacy systems, right? So it's actually important to get the data from these systems and then put it out onto a centralized system. So what we are seeing is how do we or what we can provide is how do we ensure that we collect the data from the field, put it out onto a centralized location for predictive maintenance, the analytics at a later stage, or building applications on the data which is collected, right? So that's what we see, where it's more about how do you connect the edge to the cloud-based systems or solutions. That's something which I would like to add in over here.
All right, thank you very much, Sandeep, for that submission. I'll go to you, Pierre. Do you also share the same view? And from where you stand, what kind of excitement are you seeing in terms of digital applications within the utilities space?
Yeah, I think in addition to what my panel colleagues said, I think we are in a very exciting time right now in the energy industry, because not only is digitalization driving a fundamental change in the classic value chain of the utilities, with all the applications from predictive maintenance to optimizing your value chain, demand forecasting, a better load management, and so on. But what is happening as well, due to the decentralization trend and the fact that digitalization and solutions are more and more available to people outside of the traditional value chain, we also see a new value chain emerging, which is more about decentral energy, which is about smart cities, and which is about consumer empowerment and utilizing the energy data that I as a consumer actually have for all kinds of new business models. And I think we're right now at the dawn of the birth of all of these business models. And if I look at the region, I think there's a lot going on. You have all the major utilities being heavily invested and heavily focused on digitalization, whether it's DEWA with Digital X and Infra X, or TAQA focusing on the several digital use cases. But you also have very, very, let's say, cutting edge kind of approaches. For instance, NEOM in Saudi Arabia focusing on creating a utility of the future from scratch. So I think this region has the potential to leapfrog a few developments, utilizing digitalization and create a really new state-of-the-art utility industry.
Yes, thank you. Thank you very much, Pierre. And I think I would like to agree with you there that the demands keep evolving every other day, which place a lot of pressure on the new requirements within the digital space. So to you, Solius, what would you like to say about the current advancements and the growing potential for digitalization within the utility space?
Thanks, Bruce. I think absolutely there is no doubt and no denial of the digitalization that is happening right now in the companies in the region and also globally. We just recently issued a EY Global Capital Confidence Barometer, and that shows that more than 2/3 of energy companies across oil and gas and power utilities are currently undergoing digital transformation. Maybe since my colleagues covered very well the external factors, maybe let me focus a little bit on the internal factors of the digitalization. Because, and this is what we see organizations, especially in the region, realizing that so far the digital solutions, the legacy digital solutions that they have built, they are mostly built around facilities, products, and assets. But when you think about digital transformation, this is mostly about human at the center. This is about people. So what organizations are now realizing that in order for them, as Pierre mentioned, leapfrog and achieve the next level of digitalization, this is the first thing that they need to fix. They need to build their new digital solutions around what we call personas, around people, be it a ship supervisor or client representative or the client itself or the prosumer, so that this new solutions, they are built for the purpose of those personas. And therefore we see a very significant change happening on the way organizations embrace digital and the way they launch those digital programs internally in their organizations.
Yeah, all right, thank you. Thank you very much, Solius, for that submission. So Today, we see cities such as Dubai, Abu Dhabi, Riyadh, and others in the region building infrastructure to evolve into smart cities. I would like to hear from you what you think the role of smart grids and smart meters will be in accelerating and fast-tracking the transition to smart cities. Starting with you, Andre, again.
Yes, absolutely. So that's a very interesting point. Smart city is something that we start learning. It's a terminology that we are start getting used to listen, to read about what exactly is a smart city. If you think about the smart city concept, it's essentially make a more sustainable, safe, and comfortable environment for our people to live in. And again, we have to think about some challenges here. So we have the urbanization, increasing urbanization, and we have the concept of switch to electricity. So again, it's we see that if in some we can somehow think about energy going mainly through electricity when we think about smart city. But we also have to understand that smart city need to have a very strong backbone in communication, because this is the key. So a smart city is a city that is able to sense data again over different direction. And we think about energy is for sure being able to sense from main distribution to secondary substation down to feeders inside the building as well. So inside each single building down until the last load in the building. If we think about the energy shift, okay, for sure, smart city is much more than that. It's comfort, it's security, comms, it's being able to analyze, I don't know, vision recognition to make more safe the city. But if we limit this in the scope of the power, that's extremely important. That a city looks like we can make a comparison. No, you can think about the smart city like a processor. You need to make it simpler, you need to make it faster, you need to make it able to manage a higher number of data, getting better result in terms of energy consumption, and reducing the, not only using the right energy, so integrating the renewable in this case, but also being able to reduce the consumption. So that's why it's extremely important that a city need to include, the smart city need to include and extend the concept of the nanogrid and the microgrid in the district by aggregating different type of consumption and generation in starting from each single district and then growing and connecting any single pieces of the city to the other in order to being able to rebalance the consumption and the generation within the city. And this, I think, before was mentioned NEOM. No, this is a, but we also have to think about cities like you mentioned, no, Dubai, Riyadh, Abu Dhabi has a lot of potential to create the right infrastructure to being able to manage from the beginning in the right way the energy usage and generation in the city itself. And then again, here is also a matter of involving the citizen in this case in the landscape, put the citizen in the center, because finally a city is built around the citizen. So and the role of the citizen to be need to be centric in terms of energy consumption, but we need to give them the right tool. And this is really what a smart city can do, can be, and what are the opportunity. I think that in particular the region can really be a pioneer when it comes to smart city. We have a big opportunity in the Middle East to grow smart city, both in the sort of the ground field or also by looking into the current cities and how this technology can be applied to existing cities. So I think it's a great momentum where digitalization will play a lot of, it will play an important role, and we need to consider communication and power distribution infrastructure for a smart city to succeed.
Thank you very much, Andre. And I think that's a very interesting submission, because the whole essence of smart cities is to have put citizens in control, put them in charge of everything, including their consumption. So to you, Sandeep, what do you read from this, the whole concept of smart cities, and whether you think the current trend in smart grids is going to help to fast track the evolution of smart cities in the region?
Right, right. So, just to echo Andrea's statement, right? So I was reading this similar thing, right? A city isn't smart because it uses technology. So it is smart because the technology it uses needs to make the citizens' life better, right? So that's where the whole smartness comes into picture. And there are a lot of smart cities, in the Middle East and across the globe, which are being developed. And one of the things that it drives is the smart infrastructure. It drives surveillance, the lighting for that particular city, and of course the pockets of areas that do develop along the lines of the smart city, right? And this also ensures, or it needs the power infrastructure or the utility infrastructure also to be developed to support these ancillaries which are being developed along those lines. And when you say smart city, it typically goes towards how do you get the data from the meters, right? For a consumer, how do you make the energy metering smart? Okay, that's one aspect of it. And what we've also seen is utilities like DEWA, ADDC, they are building these infrastructure where 100,000 meters are being connected to a centralized NOC, where they are monitoring all these systems, right? And then if there is a smart city, then there might be solar parks which are coming up close to flat to ensure that they pump in more energy, right? Again, it comes back to the digitalization aspect, where how do you ensure that the data which is there in the field, the data can be gathered, and how do you ensure that the lives of the citizens could be made better in terms of safety and security aspects as well. And I would say utility is one of the major parts which plays a role in this particular one. So another thing, what I also look at it is the EVs, right? The electric vehicles, and when you're basically charging your EVs, it also needs to be a part of the entire smart application, right? So these are some things which I feel are going to go further as a part of the smart city infrastructure.
All right. Yeah, thank you very much, Sandeep, for that submission. I can see Pierre is dying to say something. Pierre, what's your take on this?
Yeah, I think if I take this from a utility point of view, there are a couple of really exciting aspects about smart city and involvement of utilities. One for sure is the whole aspect of providing smart grids that will actually unlock kind of autonomous microgrids in the future that are able really through digital twins of assets to really do autonomous transactions and autonomous balancing in certain districts. And that's not too far away in the future. If you look at other countries, it has already been implemented in huge pilot projects. We've done something similar in Germany for a district that was trading autonomously peer-to-peer in a smart grid. But I would also like to highlight a different aspect, and that utilities have a really unique chance to play a major role in smart cities outside of what immediately comes to your mind when you think about utilities, and that would be the grid. What we're seeing right now is really a convergence of industries, a convergence of the utility industry, of the telecommunication industry, and of the transportation industry. And the convergence of these industries really unlock very interesting business models that normally a utility would be best in position to take the lead, whether it's smart street infrastructure or setting up communication along the city. And also here, even also if you look at the region, we see, for instance, DEWA going into that direction. globally, we see a lot of international utilities going to that direction as well. So utilities, in a nutshell, from my point of view, really have the chance to be the backbone of a smart city.
All right, thank you very much, Pierre. And Solias, do you agree with that?
Yeah, I think Colin said very well the feature spot of smart cities, and it is very much about the technology, data, and people. This will provide really completely different experience to citizens of those cities, and also different opportunities for building out new infrastructure, as colleagues described. I would like to cover also the business side of it, because and of course, smart meters, they will provide a lot of data, and that data can be used not only just to issue the bill, but also to understand what is happening in the real estate market, for example, to have lead signals for insurance services and others. So I agree very much what Pierre said, that utilities, they are the first in line to be able to capture those opportunities. The key challenge for them would be to understand, do they have those capabilities in-house to be able to engage in those new businesses, and how can they build out those capabilities? And this is what we're hearing from our clients. So we did the survey, the digitalization survey among the key utilities around the globe. And number one challenge that they mentioned was not related to technology, was not related to data, but was related to the existing people capabilities in their organizations and their ability to embrace those new services so that they are able to deploy them and offer them to our clients. So I very much agree that smart cities, they will provide unique opportunities in technology and data, and also new businesses. And utilities can really capture this. But number one thing that they will need to address is their own capability in their organizations.
All right. Thank you very, very much, Solias, for that insightful submission. One other thing I wanted us to talk about is the way the coronavirus pandemic has unlocked the potential of remote operations. And so I just want to see how we can apply this to utilities and try to see how utilities can unlock the full benefits of remote operations while maximizing productivity, OPEX, and efficiency in power plants with the help of new digital solutions. Starting with you, Andre.
Sure. No, I think here the pandemic for sure helped in any case the digitalization. I think that one of the aspects of the pandemic is that push all the operations, not generally, not only the concept of remote working for white collar, but also try to find a way to use remote connectivity to do the same activities that was done before, that were done before in place by remotely, and this is something that we are developing since years in our product. No, as ABB, we always include connectivity directly in our product for us. And the demand that, and it's also what we see when in the demand of our customer is always having a solution that can be monitored remotely. And when we think about substation, when we think about building automation, energy management behind and after the meter. So it's all about being able to collect the signal, analyze the data, and present it in a very, very seamless way into one single pane of glass. This is what customers want to do. And finally, just operate when you exactly need to make a maintenance, for instance. So this is also not only reducing the cost of maintenance, but it is also dramatically reduce the outage. The reason why is because you don't have to, you can work in advance before something is happening, before there is a fault or before you need to switch to a different to a different feeder because the primary feeder is out of power, for instance. So you can react faster and being able to avoid outage and remote control the distribution system, staying safely behind your desk. This is also reflected not necessarily only in the fact that you cannot access the site, but is also preferred to stay off the site where the site is energized. Think about a gear or a substation. You may want to control this safe under your desk instead of entering inside the room where there is the risk of electroshock. No, in any case, you want to stay out. So technology in this case is really improving a lot from a OpEx point of view, from a safety point of view. So I think this is really a quantum leap that we saw in managing our equipment, our asset, and reducing cost in the same time.
Well, so the pandemic wasn't that bad after all. So we managed to learn a lot of things, including the benefits, the full benefits of remote operation. So Sandeep, could you also share your thoughts on this and how utilities can really ramp up their remote operations with the help of digital solutions, especially from the lessons that we've learned from the pandemic?
Sure. Right. So just to make it a little light, right? There was a question asked. I mean, this is something which is trending on all these social media channels. Who led the digital transformation of your company? Was it your CEO or was it your CTO? Well, most of them said it was COVID-19, right? So, well, this pandemic definitely has taught us a few things, especially when it comes to remote monitoring and remote asset management, right? So one of the main reasons for that is people now, the engineers, the operations and maintenance folks, they are no longer ready to travel to certain remote locations. The reasons are very well known. And there are certain digital tools. It may be a combination of a hardware, a software, and a complete solution where you could ensure that the remote monitoring is done pretty much easier and it is secure as well, right? See, because the moment you say, how do you do a remote monitoring? Everybody looks at, okay, I'll probably install a device and then try to take the data out from those devices. But is it secure enough, right? So that's something which the IT aspect comes into a picture. That's where the IT-OT integration and the remote monitoring and maintenance comes into place. And there are several remote monitoring solutions which make utilization of a pretty good encryption technology, encryption algorithms at the back end, and ensure that one, it is easily available 24/7 for a operations perspective. And two, as Andrea pointed out, when you are doing these monitorings online, you will also be able to do that sort of a preventive or a predictive maintenance, or you will be able to get the information back from that. And so sometimes what also happens is these maybe a substation or maybe if you look at a telecommunications tower, which is having its own small maybe a generator or a utility unit. So just to reach that particular site, it's going to take such a long time, right? Physical travel, it costs money and it costs engineers time to travel. So if these new age remote connectivity solutions can definitely be deployed, and this will probably help in resolving the issue faster than the normal, you can say, pre-pandemic era.
All right, thank you very much, Sandeep, for that submission. So Pierre, what do you see in this space? How do you think utilities can ride on the lessons learned after the pandemic to ramp up their remote operations?
I think for sure the pandemic was the catalyst of acceleration for looking with more seriousness into all of the topics of digitalization and remote operations. I would see probably three main areas that utilities are following right now, or they should follow right now. I mean, the first one is create the basis for digitalization. So I think the pandemic and the shift to a sudden remote work really showed that a lot of companies were not yet ready, in the sense that data pools were not harmonized, you had different systems and so on. That's why you see a lot of utilities really focusing now on significant IT transformation programs to create that harmonized kind of data lake that will unlock a lot of digital applications. So that's one thing, create the basis for digitalization from a technical point of view. The second, and here I'm linking more to what Saulius said about the capabilities, and that you need to ensure that utilities can also implement it at their own pace. It's a phase of, let's say, co-piloting between human interaction and digital solution to, on the one side, gain trust and gain experience in managing these digital solutions. And on the other side, also implementing solutions that have a good maturity level and not, let's say, jump on, let's say, very fancy topics that might sound fantastic, but they bear a lot of risks. So if I say use cases that have a good maturity, predictive maintenance is a very well-established field in the meantime. So that is something that utilities should definitely fully embrace if they haven't done. This will unlock better load management, forecasting, real-time tracking of assets. And the third point, but that would be from my point of view, probably 3 to 5 years down the road, is the shifting gears to really creating digital twins of utility assets, whether it on certain middle layer systems or even using blockchain technologies or very interesting projects like the Energy Web Foundation to then have the next level of autonomous interaction of your assets.
All right, thank you. Thank you very much, Pierre, for those insightful thoughts. And I think predictive maintenance is a very good area that that utilities need to pay attention to. And today we see, when it comes to remote maintenance, the adoption of drones, drone technology. I think DY is already using that. So I think that's a good sign. So to you, Saulius, what are your thoughts on this?
Yes, well, I think you mentioned the predictive maintenance and the assets angle. And I think this is what is a bit unique about this region. If you look in the US and most of the European countries, you would very often find some assets in the grid or oil and gas entities that are dated before the Second World War. Actually, you can even find some that are dated before the First World War, if you really look. This region is benefiting from the fact that most of the assets are extremely new. And by the way, quite a significant amount of assets are already smart. So in most of the utilities, you will see most of substations, especially high voltage substations, being smart substations, generating gigabytes of data every day. You will see hundreds of thousands of sensors deployed already for a few years in the major oil and gas facilities. But then, what our clients are realizing when they look at those assets, they realize we have all this data, but we're not using that yet. Number one, this data is not calibrated. So you may have 5 different temperature meters, sensors in your substation, and you don't know which one is giving the real temperature and where is it exactly placed. So what they are now discovering, that they already have a significant asset base that is providing very valuable data. And now for predictive maintenance to work, or also for digital twin to work, you need to make sure you're able to capture the data, calibrate the data, capture the data, and make sense out of it. So we see this link between OT, operational technology, all the sensors, meters, everything that you have in the field, and your IT, so systems where you would run your predictive maintenance, converging. And that will be very interesting next step and next challenge for both utilities and oil and gas companies in the region. And this is where they can get really ahead of their peers elsewhere, because again, most of the assets are brand new.
Right. Thank you very much, Solias, for sharing your thoughts on that. As the Middle East embraces new sources of power generation, this presents a new challenge of integrating multiple sources to the grid. So starting with you, Andre, how is technology enabling a seamless integration and addressing challenges related to power intermittency and other challenges?
Yeah, yes, again, here, I think I touched in the first question, and I can connect and I can connect here. I think that the integration of the renewable is something that for sure need to take in consideration digitalization. Why? Because essentially, if you think about the difference between a old conception of power plant and versus the renewable are very complex to predict how much energy you can regenerate. If you think about solar or wind, is always about being able to understand what is the energy that you can generate in the next 1, 2, 3 hour, 5 hour, half a day. So you need to create, in this case, the data and the digitalization can help you to generate the forecast of the generation and the demand, because finally you need to create a balance between the two and eventually understand whether or not to use storage of energy. That, by the way, it's an important component of the integration of the renewable. But finally, here again, we have to speak about data and about sensing and being able to use, in this case, algorithms and competencies to balance the energy generation with the energy forecasting. Moreover, the generation through renewable is becoming more decentralized. So it means that we have small plants that are placed in different parts of the grids that you have to consider as and that can generate different level of, for sure, can provide different type of different level of power and energy. And so all this decentralized plan needs to be considered as a sort of virtual plan. And how you can do this without the right sensor, without the right analytics to make prediction, and then decide, take actionable decision on how to rebalance the generation with the demand. And eventually, this is where also the consumer can play a role, no? Because finally, this there is the concept of the demand and response also that need to be taken in consideration. So putting again the consumer, the prosumer, I think Silvius, you were using this word before, prosumer. This is what we are going to see in the future. Consumer will no longer, energy will no longer go from the big power plant down to the last consumer, but is going to be generated, distributed, and routed. We can think about calling, instead of solving the problem of distribution, we should call this solving the problem of routing energy between the different generation and consumption point. So, and this is where digital can play an important role. So while developing competency in with analytics that can solve this problem.
All right, thank you very much, Andre, for that, for those insightful thoughts. So, Sandeep, what's your take on renewable energy integration and other multiple sources of power generation? How can this be seamlessly integrated into the grid with the help of digital solutions?
Right. So what we are seeing here is that as the cities expand, right, the demand for energy is increasing. Now, the only way that additional energy could be added into the grid is by probably using renewables like maybe solar, wind, all these sort of generating possibilities. And what can drive this is if you are able to do a sort of information gathering. Okay, this is the peak, and during this peak we would need to have this extra additional power which has to be generated or which is already generated to be provided to that particular load, right? So that is where what I see is the dependency on the renewable sources and the exchange or the load balancing between what is already being generated versus what extra has to be provided to the grid. Now, this can only happen if, again, if the data is available as to what is the current demand and what is the predictive demand which can happen during the peak loads of the day, right? So again, if we are able to connect these different grids together into a simpler or a single form of a grid and able to check what is the threshold and then do a better management using the digitalization techniques, that will probably benefit the utility and the city as such.
All right, thank you very much, Sandeep, for your submission, and I totally agree with you. I mean, with renewable energy, especially solar in this region that's being widely adopted, not being dispatchable, I think this seamless integration is really important, and this is where digital solutions can play a big role. So to you, Pierre, what's your take on this?
Yeah, while my colleagues, I think, rightfully focused on the distribution aspect and
hello,
can you hear me? Hello. Okay, I think the other participants can hear me. Okay, so I think while my colleagues focused on the distribution side of things and on the renewable energy production side of things, let me add another perspective to that as well. I think it's really important for utilities to respect the fact and be aware that there's significant innovation happening behind the meter, which is a territory which the utility is not in today. And what I mean with that is that through consumer devices and through other devices that enable customers to have a better understanding of their energy consumption, of the energy data, even on a device level, there's a whole, let's say, new untapped data pool that someone for sure will monetize and someone will capture to basically create decentral business models. So I think utilities really need to focus on that, because right now for utilities, one of the main assets that they have is the huge amount of customers. And as long as that access is there, from my point of view, this is one of the central focus points that utilities need to focus on. In particular, if we think about this region, because it's still a kind of a protected environment. If we look at other markets like the US or Western Europe, then the regulator is not protecting the retail space and is opening that up for competition. And you already see a lot of competition from startups, from even oil and gas companies and from telecom companies going into that space, fighting for business models behind the meter. So for me, getting control of behind the meter business is key for decentral utility business models in the future.
Thank you very much, Pierre, for your thoughts. Saulius, what's your take on this?
So I would like to extend on the point that Pierre raised on the business side of it, because if we look at the changing energy portfolio in the region, and you mentioned renewables, of course, solar predominantly, but also we have nuclear coming in, and these are very different type of generation sources. Some of them intermittent, some of them fully stable baseload. And that means that we'll create an opportunity. So some opportunities will emerge on the distributed generation side and on the consumer side, as colleagues already described. But there will be also overarching opportunity from an electricity trading perspective. and not just peer-to-peer trading or consumer trading, but also trading the overall the bulk electricity. And we already have very strong emerging trading organizations in the region, in the likes of ADNOC and Aramco and other NOCs, that are mostly focused on the feedstock and on the oil products trading. But now there is a new opportunity emerging in terms of electricity trading. And of course, we still have too little interconnectivity between the countries. Traditionally, again, the market was not open yet to the point where this trading would take place. But we see that is something that is fast approaching, and that will be very exciting for utilities or their peers in oil and gas to capture this market.
All right, thank you. Thank you very much, Saulius. Sandeep, you earlier on talked about security of, security of systems as we try to embrace digital solutions. And I understand there's a lot of cybersecurity concerns within the utility space, and this remains a major barrier to the adoption of digital solutions. So what steps do you think are being taken to address this concern?
Right. Thanks for that question on the security or the cybersecurity per se, right? See, what's happening now is the digitization, or if you can call it as IoT 4.0, all these terms, right? So when this is happening, you have more and more equipments which are being smart, which are being connected to different systems and different applications. So this also increases the cybersecurity threats, which can be sort of an entry point for the hackers or for the bad elements, and they try and hold the customer to a ransom, right? So what we have seen as a trend is that earlier, when the cybersecurity attacks were happening, these were sort of random attacks, right? So these were not very targeted. So of late, what we have seen is these are all very targeted attacks. Specifically, if you look at the nuclear power plants, if you look at the factories which have been targeted, right? So these are very, very specific cybersecurity attacks which are happening. And the other terminology which Saulius used, right? The OT-IT integration which is happening. So this is basically to ensure that even when you talk to the OT personnel, they always say that the systems that are used are not easily understood by the IT, right? When you talk to IT, they say these are protocols which we really don't know and we really can't do much about it, right? So this OT-IT integration plays a major role in ensuring that IT, basically, who is, you can say, the owner of the complete network of maybe a power plant, is well aware of what is there, what are the threats that they are facing. Now, there was another survey which was conducted by an independent software vendor for cybersecurity, and they found out that something like more than 75% of the customers did mention that cybersecurity is a major concern, but they were a little reluctant to actually do something about it, right? Because everybody knows that there needs to be additional probably hardware to be installed. They know that these are all the protocols which might not be easily available in the market. And that's where we also see that it's one of the leading concern for any business operation. And all the products are now trying, you can say, they're all coming on the same IP platform. And so one of the emerging technologies for this, or the emerging standards, is for the industrial automation control system, is the IEC 62443. And a lot of the OEMs, a lot of system integrators, and solution providers are trying to base their solutions on the 62443 platform. And we are already seeing that the customer, end user, the utility is also already, you can say, educated about this, and the newer requirements, especially when it comes to the networking portfolio or the networking per se, they are demanding these sort of standards, right? Because what I define as security might not be the same security which is defined by somebody else, right? So there has to be a standard, and this standard is something which is driving the industrial automation control systems industry as such.
Well, thank you very much, Sandeep, for that submission. Andre, at ABB, you are involved in a lot of these digital integrations, and I believe you are mindful of the cybersecurity concerns. So I would like to know from your end, what are you doing to address these concerns, and what steps generally are being taken by the industry to address them?
Sure. Speaking about ABB, I have to say, backing into 2016, we start developing our IoT platform that is called ABB Ability, and then we create this with the design of cybersecurity in mind. It's today the topic of converging IT and OT world into one, which is what we are trying to do with Ability. Is definitely the cybersecurity is definitely one of the most important aspect that we have to consider. It's not a functional aspect; it's a non-functional requirement of any digital solution. It must be secure. There is no branding. This is one of the first priority customers ask us. So, how much a solution is secure? And I have to say that security is not a product, it's a process that needs to start from the design phase and continue during all the operation phase. When it comes to the IT-OT integration, I think that an important role on the cybersecurity plays the role of the gateway, the H part, that I call it gateway, and I want to stress this concept. Is not a gateway between, I don't know, you can imagine on-premise and cloud. It's a gateway between the OT and the IT world. And this is where it's extremely important for sure for us to ensure security, because it's like a door to the asset. And if this must be secure, and this is where we put a lot of effort. For sure, we also play with or base our platform with a lot of technology partner also from the cloud infrastructure. So I think security is one of the most important process that we have from design down to operate our solution. For instance, when it comes to software as a service. So again, it's important that we can secure the overall system, starting from the field protocol, backing into the gateway to the edge computing, which is becoming even more relevant going forward, because the edge is going to be the control point of any system, and for sure ensuring the security in the cloud. But I have to say that in the conversation we are having with customer, and in particular with the utility space, for sure utilities embrace the concept of private or public cloud to scale their technology and their capabilities in data and analytics. But I also demanding security go down straight to the asset. So it's cybersecurity is really present in every single pieces that we manufacture, from a relay, a breaker, a switches, up to the last analytics in the cloud and the front end in the cloud. So I have to say that we always, and we see this as an important driver. And with our solution, we always put a lot of effort in adhere with the standard, comply with requirements. We have a lot of check regarding cybersecurity. So we are taking taken it very seriously, but I think that overall the market is taking it very seriously.
Yes, right. Thank you. Thank you very much, Andre. So Pierre, do you equally think that the right steps are being taken to address these cybersecurity concerns that are proving to be a barrier to adoption?
Yeah, I think from point of view or from our experience with global utilities, I mean, cybersecurity has always been kind of one of the major topics in utilities. It now got amplified due to the move towards digitalization. So I think the approach that we probably see around the world on average is maybe more on a very conservative side of things. And you could argue rightfully so, because energy assets are the most critical assets that you have in a country. However, a trend that we see is that clients really use, let's say, approaches that you maybe 5-6 years down the road could only see in big tech companies, namely hiring white hat hackers to do vulnerability assessments, and then coming up with a proper plan of what needs to be fixed. That's one point. The other point is, I think we, especially in this wider region, and looking to Israel and Tel Aviv in this case, there is an immense growth of cybersecurity startups and technologies, especially for the energy sector that is developing. So also here, the region in a wider sense can really play a role of exporting relevant technology. And then the third point is, I think cybersecurity, obviously going down the line, if we really think about a vision where we have machine-to-machine interactions in an autonomous grid that might even have auto payments with cryptocurrencies or specific tokens back and forth, then cybersecurity becomes the core competence of maintaining the system.
All right. Thank you very much, Pierre. Thank you very much for that submission. Solias, what do you think from where you stand? Do you think the right steps are being taken to address this concern?
Yeah, I think so. Probably to add on what colleagues said, two additional points, and the need for solutions and the drive for solutions that we see organizations in the region are extensively looking at. So number one, because OT and IT conversion that colleagues already described very well, that also uncovered the vulnerability of OT part. Because one thing is when your OT assets are separate, are not connected, are not interconnected. So this is one thing to protect them. Another one is when they're exposed because they are connected to your IT assets. And then what organizations realize, because their assets, they're based in multiple locations and they're distributed sometimes along huge territories. If you think about Kingdom of Saudi Arabia, for example, what they are concerned about, first of all, in order to protect the asset, you need to know what is your asset and where your asset is. So number one solution right now that we see organizations looking at is asset discovery, OT asset discovery, to make sure that they're able to inventorize, identify, and locate those assets, and then of course follow up what patches are being made, what kind of maintenance, who was the last one who uploaded the last firmware to those assets. So that's one. The second one, and goes back to the point that I think Sandeep mentioned, that IT and OT organizations, they are usually separate and sometimes silos in most of the energy companies historically, because OT was always originating within the asset owner. So it would be a power plant, or it would be someone who is running the grid or refinery, and IT would be a corporate function. And those are still separate. So what organizations are looking at is how we can build bridges between those functions for them to work together and collaboratively to address this challenge. So I would say these are probably the two key solutions that we see now the strongest demand currently in the market.
Well, that wraps up our discussion for today. Thank you all for your participation. And I hope you all enjoyed being part of this insightful panel discussion. I I think you all still have a lot to say, but I'm afraid we run out of time. A big thank you to all our viewers who have tuned in from around the world. We will be back shortly with our next session on accelerating renewable energy adoption in the Middle East. Stay tuned.
Thank you very much.
Bye.
Thank you. Thank you very much.
Bye-bye.
Bye.
Thank you very much. Thank you.
Every day, we are learning more about our evolving world. Every day, ideas are born. Challenges become opportunities. To succeed, we need people with the vision, passion, and the knowledge to turn opportunity into reality. That's us at ABB. Thinkers, engineers, scientists, innovators. The ideal partners to unlock customer value through the domain expertise of a digital pioneer. We have the strength to realize the once unthinkable. Writing a future where cities are free from traffic emissions. Where buildings produce more energy than they consume. And renewable energy knows no borders, traveling across countries and continents. A future where machines can tell us how they feel, where ships with sensors communicate to navigate more efficiently. A future where robots work hand in hand with humans. We are driving the progress our world needs and creating value for our customers with smarter, faster, more reliable solutions. And joining forces with Formula E is a major part of our mission to make the electric revolution come true. Day after day, we bring visions to life. Let's write the future together. ABB.
We live in an exciting age of intelligence, inspired by the Internet of Things. It creates entirely new prospects for all industries and make people's lives better. To unlock the power of this transformation, connectivity is critical. Connectivity solutions that work reliably in harsh environments. Connectivity solutions that do not compromise on security, ensuring maximum protection. Connectivity solutions that integrate seamlessly with your existing machines and IT platforms. With over 30 years of experience, Moxa has successfully deployed IIoT connectivity solutions from the edge to the cloud. Together with our partners, Moxa has helped customers in more than 70 countries realize their digital transformation. It transformed daily operations for this American manufacturer by getting real-time insights from machines. It transformed this Taiwanese factory's IIoT strategy, increasing OEE from 70% to 85%. It transformed this Russian industrial gas manufacturer's remote monitoring system and enabled predictive maintenance for problem diagnosis. It transformed this fuel cell manufacturer's business model, reducing their labor force by 50%. It transforms the way you operate and deliver. Moxa is enabling IIoT connectivity to help create intelligence to build a better tomorrow.
Welcome back from the break. We had some very interesting conversations from our earlier session discussing digitalization and its potential in transforming the energy value chain. In this session, we are going to talk about accelerating renewable energy adoption in the Middle East. I'm sure we all agree that the region has, over the past few years, performed very well in terms of renewable energy penetration. We see many countries in the Middle East on track to meeting their set renewable energy targets. This session will therefore track the progress made and lessons learned so far, propose solutions to emerging challenges, provide industry foresights, and share expertise on latest innovations designed to meet the evolving needs of the market. To discuss this topic, we are joined by a panel of senior executives and prominent experts who have distinguished themselves as strong proponents of renewable energy in the Middle East. On this panel, we have Rizwan Razak, Chief Technology Officer at Huawei Fusion Solar Middle East. Hi, Rizwan. Welcome to the panel.
Yeah, hey, brother. How you doing?
We also have Walid Al-Hallaj, Head of Business Development, Middle East and Africa at Jinko Solar. Welcome to the panel, Walid.
Thank you, Basit. Happy to be here.
We're also joined by Daniel Zivitz. I hope I pronounced that correctly. Daniel is the CEO of Enaware. Hi, Daniel. Welcome to the panel.
Thank you, Basit.
Lastly, we have Bart Cornelissen. Bart is the Partner Energy Resources and Industrials Leader at Deloitte. Hi, Bart, and
thank you very much for having me.
And of course, I am Basit Ashaba. I'm the editor for Utilities Middle East and your moderator for this session. As we emerge from the effects of coronavirus, I would like to get your views. How has this pandemic impacted the renewable energy industry in the Middle East and its future as a key component of the region's energy transition? Starting with you, Rizwan.
Sure. So from the impacts of the recent coronavirus ongoing just over a year now globally, we have seen a lot of changes being impacted in the, let's say, availability of sourcing equipment, along with the ongoing of maintenance of plants that are being constructed or being operated, and the reliance on, let's say, suppliers specifically has been quite fierce from a perspective of getting, let's say, manpower or products into specific countries that potentially are at restrictions. So from Huawei's vision, we've always seen a more digitalized format on plants. And this is the vision that we see going forward, specifically with our equipment that we are supplying, to ensure that the equipment is fully adaptable to be connected anywhere in the world. And for the monitoring or for the diagnostic purposes, it can be diagnosed very quickly and very efficiently using the online systems that are available from our platforms or from the equipment that we are supplying.
Well, thank you very much, Rizwan, for your insightful submission. So let's hear from Walid. So from where you stand at Jinko Solar, what has this pandemic meant for you and for the entire renewable energy industry in the region?
Well, it has been a rough year for everyone, for every industry, basically. But we came up with some good aspects, some good results as well. As Rizwan says, we had some problems in deploying or the construction or the logistics of certain projects, which has caused some delays in some of the big projects in the region. But also, it also showed some good advantages, especially in countries that are dependent a lot on importing their energy needs, such as oil. If we are talking about the Middle East region, we're talking about Jordan, Syria, Palestine, and such countries. And basically, these countries or everybody managed or knew that there is a possibility to have renewable energy, which is very resilient and it's actually independent. It's a station, whatever you're doing, it is out there generating electricity from the sun. So there was some delay in some of the projects, but people have now more trust that renewable energy could be and should be part of any energy mix in the future. And to be honest, there is a lot of increase on demand on distributed generation. So people are actually pushing now to have a decentralized system much more than ever, because basically it's a tough time financially. So everybody is looking where to save some money, and definitely booming the distributed generation sector.
Well, thank you very much, Walid, for highlighting those challenges, especially on the logistics of it. So let's hear from you, Daniel. What opportunities or challenges do you think emerged out of this pandemic?
I think it's worth saying a little bit about what we do, right? Enaware is a utility company. So we service commercial and industrial clients that don't have a connection to the government grid by providing on-site generation, not just during the day when the sun shines, but also at night. So we build solar hybrid plants, either solar diesel and solar battery. And the first thing that maybe we should have expected, we didn't entirely, was that the electricity consumption in our sites didn't actually drop. Why? Because most of the industries that we serve, construction, hospitality, mining, still operated. They were construction, for example, and the upstream part of it, the quarries, were designated as critical industries. So their activities, after a few days delay, went on nearly as planned. And surprisingly, even the hospitality sector did quite well, because after the lockdowns, a lot of people tried to get out and do something different. They couldn't fly, so they got themselves a hotel room on an island somewhere. And in that sense, we noticed what I guess many utilities around the world saw, that electricity consumption shifted in some cases in terms of the timing of the day or the weekly consumption pattern, but it didn't drop as much as many has expected. So in that sense, our challenges were much more around how do we keep the lights on and the business running, even with logistical restrictions, right, with travel restrictions, but not really so much on the business itself. As a critical infrastructure provider, we provide reliable electricity, and we save money, and we save emissions. And those are things that you need, pandemic or no pandemic. So it's really more the delayed effects of the hit on the economies in the UAE in particular. Dubai obviously has been impacted quite a bit by the travel restrictions and by the slowdown in tourism and in the real estate sector. So we're seeing some of that now, but the epidemic itself had next to no impact on our business.
Very interesting. Thank you very much, Daniel, for that submission. But from where you stand, I believe you have a 360 view of the renewable energy industry in this region. So what do you see? What's your reading of the impact of coronavirus on the region's renewable energy sector?
Thank you very much for the question, Basit. I want to give a slightly different perspective than the three other panelists, because they talked, of course, very much about the challenges they face in the business, in the projects that they have as a result of COVID, which of course have been challenging times. But I think also another angle to this question is, what has happened in behavior? Is there a trend? How do things will change in the longer term for renewables and electricity? And what we've seen really happening during this period is that even though there was a decline, of course, in energy, the demand in electricity dropped a lot less. And within that, of course, renewables was still very, very strong. And we've seen this also continuing with the projects that are run and announced. If we see, for example, the discussions around hydrogen, a key factor in renewables for the longer term. You see the discussions there with Mubadala, with Masdar, with NEOM and KSA. These projects keep on going on. So for the longer term, I really feel that COVID has not had a negative impact on the energy transition we're going to see in the region. We, of course, still have a long way to go, because if you compare the position of renewables in this part of the world compared to, for example, in Western Europe, it's still relatively small.
All right. Thank you very much, Bart, for that submission. And I think I'm tempted to agree with you on that point, because from the market reports that we've been receiving, there was very limited impact on on utilities in general compared to all the other sectors of the economy. And I think this perhaps came across as a vote of confidence and perhaps to reinforce the need for more investments across the utilities value chain. Daniel, is there anything you'd like to add to that point?
No, I can only concur, right? The electrification is ongoing, and that will only accelerate with electric vehicles, with more thermal loads migrating to electric forms of electricity, simply because it's cheaper. In the region, the base assumption has always been liquid fuels are the most available. Even gas was a late arrival. You see some countries like Saudi Arabia and Kuwait still burning liquid fuels. That has been supplanted largely by gas over the last couple of years. And now comes renewables, mostly in the form of solar here, but also some wind. And every time you actually see a reduction in cost together with a strong reduction in emissions. So I think that roadmap is not going to be held up by a few months or even a few years of a pandemic. Those are driven by fairly fundamental technology trends, by political trends. And you see that at the macro level, where countries are decarbonizing and moving to renewables on the grid scale, and you see that in the micro level, where again the economics for us are very, very clear. If I have the choice of running a solar plant, producing power with a solar plant, or running a diesel generator, the solar is both cheaper and cleaner. So the only reason why I wouldn't do it is somebody prevents me from doing it, and that can be space constraints, that could be requirements for power at times of day when the sun doesn't shine, and then I need to wait for batteries to get cheap enough, right? But electrification is here to stay, and I think it will actually accelerate over the next couple of years rather than slow down.
All right, great. Walid, is there anything you'd like to add to that before we move to our next point?
Basically, the gentleman said everything. One thing that is interesting is that look how much more stable renewables were compared to oil and gas in the past year. Look at the price of oil, what happened, and how did that affect many utilities and IPPs, and look at renewables. It is actually much more reliable, and it showed the world that it can be much more reliable.
Thank you very much, Walid. And at the moment, most renewable energy companies and utility solutions providers are in a race to see how they can achieve grid parity. And for this to be done, technology will play a big role. So I would like to know from you, starting with let me start with Rizwan. I would like to know from you, what are some of the advancements in technology that you are seeing at the moment that are helping towards achieving grid parity? And at the same time, do you see any opportunities or benefits or challenges in integrating PV rooftop solar into businesses?
So to give, let's say, a clearer perspective of Huawei and our integration into the renewable plants, specifically in the solar. So we are an equipment supplier for inverters, and that equipment is also going into the technology of storage as well. So as explained previously, the integration of multiple different technologies, such as the storage and also the solar, will need to be combined as a package to provide a more, let's say, consistent power source to the end consumer. Now, another factor which is being impacted is the technology changes which we are seeing already in the last couple of years. The PV module industry has changed very rapidly, specifically with the power class of the modules rapidly increasing well above 600 watts. And the integration of that, specifically with the equipment such as the inverter, need to be accommodated to ensure that the equipment is not, let's say, clipping the energy, but also generating it in the most usable way that is being generated from the PV modules. So Our next generation solution that we're providing, which will be more of a DC coupled integration into the plants, will allow that energy to be very efficiently generated from the PV plant and shifted over, if needed, directly to the ESS equipment on a DC level side. And this is something which is changing in the industry predominantly at the moment. Either it's a storage PV plant or it is a PV plant, which is directly. So both of these are separated, and the integration of both of these together will be something which the consultants in the industry and let's say the consumers will start to see changing very quickly.
All right. Thank you very much, Rizwan, for that submission. So to you, Walid, I understand that JinkoSolar recently you've been rolling out a series of new models, PV modules that are considered to be more efficient. So I would like to know from where you stand, how you see these advancements in technologies and how they are aiding the drive towards grid parity. And if you could also talk about the opportunities that this will have in integrating the PV rooftop solar.
Well, as Rizwan mentioned before, I think the most important thing is to keep on reducing the levelized cost of energy. This is the optimum task, and this is what everybody has been working for. We have been working with companies such as Huawei and working together in having a total solution that generates electricity at a cheaper, more efficient way. So basically, as Rizwan said, there have been years on developing the cell level of a module. We have came up with the PERC as an industry. We have come up with the PERC. We switched to the half cut and multi-bus bars and so on. And then the industry shifted to a little bit developing the module itself. So modules are getting bigger. You see this, the cells are getting bigger. We switched from the M0, M2, the M4. Now we are talking about M10 at JinkoSolar. And basically everything is designed to make electricity much more cheaper. And looking at the numbers we hear in the region, I think it shows how competitive and how pushing the region is. In terms of rooftop, I think that the biggest challenge in the region is the fact that electricity is too cheap in certain countries because it is heavily subsidized in certain countries, especially in the Gulf area. We have seen in the past few years these countries switching the subsidy methodology to freeing electricity prices. We have seen that in Saudi Arabia in 2017. We have seen that in Oman in 2021. And now it is becoming much more feasible or financially makes much more sense to switch to a much cheaper, cleaner type of electricity generation. So we see massive opportunity in the region. Basically, always the challenges will be regulations because things move a little bit slow. Even if in countries that has been doing amazing job in the utility scale, there is still a lot of regulations and adjustments that are needed to be done in order to have a much more sustainable distributed generation market for the rooftops.
All right, thank you very much, Walid, for that submission.
May I actually jump in there because I happen to disagree, which is rare on these panels. So
yeah, that's why I was coming to you, because I knew you would disagree.
Well, I think I simply don't disagree with the fact that solar needs to become cheaper to be competitive. We are today in the distributed sector typically at half the industrial tariff of in Dubai, for example. From a levelized perspective, and even in Oman, in Saudi Arabia, and in most of the other countries in the region, solar is already more than able to compete on price. We're not even talking about utility scale, where solar is literally 5 times cheaper than nuclear power and half the price of gas. So solar during the day today is cheap enough. There's no need. It's cheaper and cleaner. It's done. The only thing that keeps it from taking over the entire energy system are the fact that the sun doesn't shine at night and the general mismatch of the demand pattern with the supply pattern and the intermittency. right? And of course, there are certain players in the industry that are not necessarily benefiting from the fact that solar is coming to eat their lunch. If you're an owner of a bunch of conventional power plants that used to be running at 60 or 70% capacity factor per year, and suddenly you have what is effectively the entire daytime solar curve, load curve, being taken up by much cheaper solar, you lose asset utilization on your generation assets and on your transmission and distribution assets, and that is not something that most commercially minded players are necessarily looking forward to. So you see that some of the grid companies are looking to slow down distributed solar in particular, because that is typically owned by the customer or by separate leasing providers, and hence it doesn't generate returns from them. While they're very enthusiastic about utility scale solar, where the benefits of solar being cheap or wind go to them. So I think the problem is not one of cost. The cost problem is solved. The problem is one, as always in an economic system, of distribution of the benefits. And if they go to a party that has less leverage than another one, then you get some pushback. The other issue that still does need to be, that requires more time and work is supply and demand. And that's something where we're getting there in the off-grid sector. So we're seeing storage making sense on smaller installations up to 100 kilowatts, and as a part of large utility scale projects, where most solar utility scale projects will now have a bit of storage for peak shaving and stabilization. But we're probably, I'd say, 2 to 3 years away from the point where solar plus storage hits the price of a gas combined cycle power plant. At the moment, you will again see a tipping point where the adoption goes up dramatically, but that's really not driven by solar being too expensive. It's really more a problem of the storage than anything else. And until then, we believe that it should actually be easier to work on the demand side. If you can shift some of the demand, whether it's from desalination or cooling, which is inherently a bit more storable, to times when the sun is shining, then there should be enough room for solar in particular to grow on the grid. And in places where wind is available, it of course makes a lot of sense to integrate it as well. So yeah, but just in summary, I don't think there's a cost problem at all. The problem was one of grid integration, one of storage, but not of cost.
Isn't there, in that sense, Daniel, another problem? And I think Walid actually referred to it, is the question of regulation. Because we are all operating in the Middle East in markets where effectively only one utility company exists. It's like when you take the European system, where even as a corporation or as an individual, you're allowed to choose your supplier. Here, I have, as an individual, I have one option. And they tell me what the rate is, and I just have to accept that. And what we've seen is that technological advances, as well as implementation of those, tend to work better in competitive markets, because innovation drives costs down. People are stimulated to be competitive. And that's not really yet happening in the Middle East. And of course, there are investments in benefit if we would allow people, like would we allow decentralized power generation? Do we set up good net metering rules and concepts? That would really drive, I think, the market here in the Middle East a lot more.
Yeah.
Look, I think sorry, go ahead.
Yeah, so I'm tempted to agree with Bart again. And I don't think the previous speakers, I don't think any of them disputed the fact that the cost is going down. I think the equipment manufacturers like JinkoSolar and Huawei, I think their aim is to make sure that actually the costs, like Rizwan said, that the LCOE goes down tremendously to make solar more competitive, not only in the short term, but in the long term as well. But again, when it comes to integration, when it comes to integrating, I think that's where we need to look at things like regulation, like Bart says, and also advancements in technology.
Yeah, may I add one thing to it, Bassett, because we always talk about technology, but we forget often to talk about the implementation of the technology. Because one of the challenges, and I think I've seen that particularly when it comes down to solar farms in the Middle East, is the quality of the workforce. So it's not only about you have the technology, but it's also, can you develop, build, and maintain and operate a solar farm as efficiently as they can do in other parts of the world? And one of the challenges you see here is the average experience with solar of the workforce. And one of the questions that we talk about the LCOE, yes, but it's all on the assumption, how long does it take before PV cell needs to be replaced? How long do we need to? And one of the things that we see in the region is that the depreciation of the asset and the asset integrity is an issue.
Correct. I would like to just add a comment there in terms of the digitalization and specifically, as you said, the cost associated to and the experience levels of the manpower here in the region is having an asset which can, let's say, be more digitalized. I keep going on about this, but it's a terminology which, IV curve diagnostic, for example. These are routine inspections that are being implemented on plants year on year, but is it being done to the correct standard? Currently, for utility scale plants, what I'm referring to here, it's done for a percentage. And is that the correct way going forward? However, the methodology should be looking at a refined way of evaluating your plant to see where are the errors happening, the degradation of modules, looking at analyzing specifically, can that be minimized? So it's going into detail and also educating the market specifically to understand the differences in technologies, the differences of how to integrate the latest technologies, and also the factors of cost as well.
Yeah, I think Bart alluded to a very interesting point on effective management of assets, because we don't only have to look at the LCOE, but also we have to look at the cost of managing these assets. And this brings me to a very interesting point that I would like Rizwan to further expand on integrating the various sources of power generation, because at the moment, this is proving to be a serious challenge in the absence of battery storage, because it's still very costly. So I would like to know from your perspective, what are some of the advancements in technologies, or what are some of the solutions that that you're coming up with to address the challenges related to power intermittency as a result of multiple power generation sources?
So let's make a clearer perspective. Typically, each renewable asset is typically seen as its own asset independently. So when we're talking about multiple different renewable sources, wind, solar, storage, and many others. Now, the integration of how solar picks up as the sun rises in the day and continues throughout the day, is the generation path doesn't follow the consumption path. So having, let's say, an offload of some of that generation, which is being generated from the PV plant and shifted over to the storage in the most efficient manner possible. So when it comes to the losses associated to PV plants, when transiting that power source from the PV modules directly to the ESS equipment, needs to be done in an efficient way. And that's the trend going forward. Huawei, as a supplier for the equipment of storage and also solar inverters, we've now developed our new solution, the Fusion Solar 8.0, which integrates the storage and solar into the plants themselves. Now, one of the other factors in our region here in the Middle East is the temperatures that are exposed to the equipment, such as the inverters, such as the battery cells themselves. And this is one of the topics which, Currently, a storage plant is typically put into a controlled environment where the temperatures are ideal for the battery cells themselves. Now, that's not the most ideal scenario associated to putting the asset of a storage plant and also the solar plant together. As I explained, the losses factored there. So a more modulated format of storage and the solar would be seen as being the most, let's say, best and optimum solution.
Thank you very much, Rizwan. Walid, what's your take on this?
Actually, everybody sees the importance of especially storage. As Daniel said, as Rizwan said, as Bart said, it is without a doubt going to be a turning point for solar in general and photovoltaic in a more precise way. And this is why actually you start to seeing some manufacturers in the solar industry switching into investing in such manufacturing facilities. So basically, I'm going to take Jinko Solar. Jinko Solar, we are starting to manufacture our own storage systems. So even as a module manufacturer, we are now switching into providing a full turnkey solution that combines both solar and storage together. And I think there are other competitors or other players in the market that are doing this from the inverter side, from the module side, and it is all because we see the importance of combining storage with solar for the next couple of years. And definitely, as Daniel said before, the load shifting is going to play a major role because basically the generation of a solar module is not 100% in shape compatible with the consumption, but still with few adjustments, with few load shifting, with few impacts of storage, you can have something that looks really, really compatible.
All right, thank you very much, Walid. I would like to hear your take, Daniel, on this point that I think is very important.
Sorry, could you repeat? What was the question?
Oh, sorry. So basically, the question was on how to integrate the various sources of renewable energy power generation, considering that intermittency remains a serious challenge. So what role can technology play in this? And the previous speakers, of course, talked about storage playing a key role in this. So I would like to hear your take on this. And if possible, if you could also talk about the advancements being made in CSP technology, because that's an area where we've not seen much traction. And at one point, this was touted to be a major solution to this problem.
There's a reason for why it's not getting much traction. If you're at roughly double the cost and you have a 4-year implementation time frame when the competition is much cheaper and can be implemented in 6 months, then you have a market problem, right? That's why CSP isn't going anywhere. I think when you're looking on how to increase renewable energy penetration in any system, the two levers that you have are the matching supply and demand organically, so shifting demand to the time of supply, or shifting the supply to the demand by use of storage. Batteries are, intellectually speaking, much easier than demand shifting because everybody understands batteries. Even my 4-year-old son does. It's easy. The only problem is it's still expensive. So we actually believe at Enaware that demand management, or rather shifting demand to the time of best supply, is a quicker and cheaper lever. And people have done that in various places in the world. Historically speaking, heavy industry has always moved to places where energy was cheap. That used to be smithing, right? Metalworking industries going to places with hills where you had water running down. Same with textiles. Later, the steel industry moving close to coal fields. And ultimately today, you have refineries close to gas and oil. You have aluminum industry, typically in places with cheap electricity. So thinking about what are industries in particular and types of demand that can be shifted to, in this region, places with lots of sunshine and shifted mostly to daytime operation, is probably one of the things that has the biggest impact. It's not the most convenient necessarily in a government-led system where other considerations play many roles, but it is a big lever. The other thing is to keep in mind that intermittency is a problem if you consider the load an absolute limit. What we've found in our own systems that it is often much cheaper to overbuild renewable energy capacity rather than to store it. That is to say, if you have a cloud field passing by over a solar plant, for example, you have to consider a 60 to 75% drop of the solar plant on a short basis, and you can put in battery storage to cover that drop. The alternative is you just put in a lot more solar panels, and if you have a drop of 50%, but you had 25% more than what you needed, you now have a visible drop of only 25%. And when the generation side, and in the case of solar, the DC side is really cheap, and a lot of the costs are on the AC side, on the evacuation, right? On the inverters, on the AC cabling, on the substations, etc., then in our experience, we're better off managing intermittency by overbuilding cheap DC side infrastructure than with expensive storage. That obviously only goes so far. You basically limit it to about 40% solar share in a flat load curve. But hey, the current renewable energy penetration in most GCC grids is still under 10%. So from 10 to 40% is a long ways to go. And if we can do that while we're waiting for storage to become cheaper, that's a good step in the right direction. And then at a later date, we can add storage to take some of those curtailed megawatt hours, and we can still then shift them to the night, right? The solar panels will still be there and still be producing 5 years from now. So I would generally say, let's not wait for storage. Let's go out and put in as much renewable energy capacity as we can, as quickly as it can, because it already pays, even when it's curtailed. And then we can always enhance grid stability later by adding storage when the cost levels are at the right level, and they're coming down every year by 10%. So we'll get there much sooner than most people think.
All right, thank you very much, Daniel. But are you going to agree for the first time?
That's going to be a challenge, is it? No, I think everybody raised some very valid points, and of course, discussions around storage are very important. And in that sense, I'm very hopeful also about the investments that are going to be done in hydrogen. I think hydrogen is actually a fantastic opportunity to address some of the challenges that we see in the system. The one thing though, and Daniel was talking about, we should build as much renewables as we can that's yes, then we're pushing supply. But one of the questions I have is, what are we really doing on the demand side? Because in the Middle East, the drive towards the energy transition and the amount of energy consumed by corporations and individuals, there's actually very little done. I always make the comparison when I lived in Europe, I drove a hybrid car. I moved here and the only car I could buy was a 5.7 liter V8. And as a result, I really want to challenge and then it comes back again to regulation and behavioral change, is what are we doing to get people to treat the consumption of energy differently than they do today? And that is for their transport, which is a massive factor, but it's also the way they live, the way they consume. And I think that's where the real challenge lies. And with that, I think a very valid point is that it's also the way the subsidies are given. It was mentioned earlier, I think, by Walid when he talked about subsidized energy. One of the things that we've seen very clearly in Europe is, if you want to stimulate behavior, you have to stimulate it through people's wallets. You cannot stimulate it through more of an altruistic perspective. Some people will, but the bulk will not. If you want to steer as a government certain behaviors, you need to think about subsidies, you need to think about taxation to really drive that energy transition. And then the supply will follow very, very quickly, because there's going to be a business case for it to be built.
All right, thank you. Thank you very much, Bart, for that interesting submission. So let's talk about wind, because there's been a lot of talk about wind, but very little action. Yet we see most countries in Europe, the capacity is growing. I think currently we are seeing over 150 gigawatts of installed capacity in Europe. So do you see the same potential for wind in this region? Starting with you, Rizwan.
Sure. So if you look at the IRENA forecast on the expected plants that are looking to be connected in the next 10, 20, 30 years, wind is going to be a big part of that asset of renewable plants. In regards to localized here in the Middle East, there would be a transition. I think there is already talks of plants being integrated into the local countries, which will be a matter of time. It will not be something which, as we saw in Europe, for example, the solarization was adopted quite a few years ago, and this is being integrated now into the Middle East. So it will be a transition of time where that will be looked into. But in regards to where and how, it will be at a point where things will need to develop in terms of the infrastructure of the grid, and that will need to be strengthened in order to accept that type of energy source into the grid.
All right, thank you very much, Rizwan. Walid, I know Jinko Solar, you are solely focused on solar modules and now energy storage, like you said. But do you see any potential in wind energy? Is it an area that you'd be interested in? And do you see it gaining any traction within this region?
Of course, wind energy is an amazing source of energy and definitely has proven its value, and it has few advantages over solar, actually in some areas. But as Daniel said before, in the Middle East, most of the countries here are still generating less than 5, 10, 15, 20% at the maximum of renewable energy. So when you are a little bit late and you start investing in renewable energy, you don't have limitations in terms of diagram of generation and consumption, demand and supply. You will go for the cheapest. And based on the climate we have in the region, sun sounds perfect solution for that, because when we target PV, we are talking about 2.94 cents per kilowatt hour in Sweihan, 2.34 in Skaka, Saudi Arabia, 1.57 in Qatar, 1.35 cent per kilowatt hour in Dhafra in Abu Dhabi. This is crazy cheap, and if you compare it to any other source of energy. And once we start reaching a point where there is going to be few limitations in adding much more photovoltaics, and if not, storage is a big player, then definitely there is going to be a need or much more focus on other types of energy. But overall, it is going to happen. An energy mix that is very mixed is very important for any healthy utility anywhere in the world.
Thank you very much, Walid. Daniel, we heard about Sakaka wind energy project, and then suddenly it went silent. We've had similar stories elsewhere. Do you see some kind of reluctance? Do you think governments are really not yet confident about wind, or what do you think is the problem? And how can this be? How can wind be absorbed into the energy mix?
Yeah, I don't think this is a technology problem, right? You have a couple of 100 gigawatts of wind capacity worldwide and nearly 100 gigawatt of new capacity installed in 2020. So the technology is mature. I think in this region, there is probably a direct cost comparison being made between solar and wind, and nearly not in all places, but in many places, wind will be slightly more expensive than solar. It's also, solar tends to be easier and faster to deploy in the sense that you just need a flat piece of sand. while wind, you actually need to do proper location studies, and it costs a bit more time, and it's a bit more complex. But that said, I think solar and wind typically provide different values, right? If you want to fill up a daytime load curve with renewable energy as quickly and as cheaply as possible, solar PV is the way to go. If you want to decarbonize an entire system and have a high renewable energy penetration 24/7, then you need to deal with the times that are out of the 8 a.m. to 4 p.m. slot. And wind, by and large, still generates power at night. Now, this depends on the location, what the thermal patterns are, right? That can be quite different. But when you compare wind to solar plus battery, most of the time wind will still be cheaper. Also, by the way, cheaper than CSP. So I think this is a timing thing, right? When you want to show that you're making progress on renewable energy, solar is quicker and cheaper. So a lot of that will go first. But I find it quite notable that Abu Dhabi, after building lots of nuclear capacity and being very, very aggressive on solar, has recently started to develop wind projects. And I believe the reason for that is exactly the realization that once the daytime curve is filled up by must runs, nuclear and solar, the question is, what do you do with the night? And it turns out wind is the cheapest option for that, even in Abu Dhabi, which has not a great wind resource. When you go to Saudi Arabia, when you go to Oman, or even to northern Kuwait, southern Iraq, the wind resource there is fantastic. It's world-class by any standard. And that means that difference between solar and wind is even smaller. So I think it's really a timing thing. You'll see a lot more wind announcements coming in the next 5 years once the initial wave of solar PV during daytime is through and the load curve is filling up.
All right, thank you very much, Daniel. But do you think we can really have a true energy mix that excludes wind? And do you think it's being prioritized well enough?
I think Daniel made many of the points that needed to be made on that. I think that we need it into the mix. The reason, and it's also been mentioned by Walid and Rizwan, is why it has not popped up yet as much as solar is I'm originally from the Netherlands, one of the windiest countries possible. We don't have solar. We don't have a lot of sun, so there's very little solar. Everything is done by wind. If you look at the big North H2, the hydrogen project right now, it's done based on wind energy. And I do think the same thing will happen here. We'll get it into the mix. But I want to stress is like we mentioned earlier the discussion around what kind of technology, what kind of capabilities do you need to develop and build, maintain, and operate solar farms. That's even harder with wind. It's a highly skilled labor force. It's complex technology. And I think the people in Abu Dhabi and other places in the region will find out some of the challenges that they have operating it. And we see that already in Oman. There are challenges operating wind farms. And that's not because the wind pattern is not there, but just because the way they're run, the people that are running them, it's challenging. And I think that's where the region, when we want to think about energy transition, also needs to think about a labor force transition or a capability transition.
All right, thank you very much, Bart. We earlier on talked about the falling costs of solar energy. But at the same time, we see that conventional power is here to stay because the need is still high for it. But do you see any opportunities of hybrid systems between renewable energy and conventional power sources? Starting with you, Daniel, because I know you have some projects that are premised on hybrid systems. If you could just tell us more about such opportunities.
Yeah, for sure. I mean, I think we're talking about hybrid systems. That's what we do for a living. That's what most utilities do here, right? You run conventional thermal assets. You try to put in as much solar as you can, as we mentioned during the day, where it's cost effective at the moment. And then you have to cover some other periods with thermal assets because the version of going 100% with storage is simply too expensive at the moment. In that sense, that's what we do every day. We've done over 60 solar hybrid projects primarily for various industrial clients, construction, mining, hospitality, various islands on short tenors, as short as 6 months, sometimes as long as 10 years. And what you find is that this hybrid configuration, because it's so modular and it can be deployed so quickly, allows you to react to changes in the load and to react to big events. That could be a pandemic, that could be a change in weather. So again, it's about diversity of sources. And at the same time, we are keen to boost the share of renewables, right? We have a particular limitation in our business that we produce power only on the client's plot. That means we don't have transmission assets, we don't have distribution assets. We produce power and we sell it to the client, and that means I don't have geographic diversity that most other utilities will have. And for wind in particular, I'm often space constrained. If I'm powering a construction site in the middle of the city, and we have an example a few hundred meters here from where I'm sitting in our office in Dubai and JLT, we have the Dubai Uptown project, which is being built by a large contractor, Basics, and we powered that construction site with a 90% solar share during the day. That works, actually, despite the fact that they have very big and variable loads, tower cranes, for example. And we could run that on solar during the day most of the time. But as they're building the tower higher, that is starting to shade our panels. And I can't put up a bunch of wind turbines in the middle of a high-rise building environment. It would take way too long. The entire project is only a 3-year project, and that's normally how long you need to permit and build a wind power plant. And then I can't have 100-meter long blades in the middle of the city. So hybridization, you have to be very specific to where it works.
I have to cut you short, Daniel, because we are quickly running out of time. Let me just give a chance to the others as well to make their submissions. So just quickly from you, Bart, I would like to get your perspective on this point just before we wind up.
I think we spoke about it already at the previous questions. There's a need really to have a balanced energy system, and that means that every type of energy needs to be part of that. It's also the energy transition. It's very clearly it's an evolution, not a revolution, which means there's still roles for oil and gas to play. There's still roles for different types of renewables, and we'll phase that out over time and build things up. But it's only possible if there's also, at a regulatory angle, if there's really a strategic perspective on what we want to do with the energy system. So far less a responsive approach, but really a proactive approach to drive it.
All right, thank you very much, Bart, for your submission. Rizwan, I would like to get your perspective on this as well. What do you think are the opportunities for hybrid systems?
Yes, I think this has already been clarified by Bart and Daniel already very clearly, that the transition will be over time with the multiple different renewables and energy sources into the grid. So that really concludes, and with my previous comments that I referred to in the integration of storage and solar working hand in hand. It clearly defines that this is already started and is at a stage where it's only going to grow even further.
All right, thank you very much, Rizwan. Walid, do you have anything on your radar regarding these kinds of systems, hybrid systems?
No, definitely everybody said everything. That is, it is a transition period. Fossil fuel will keep playing a decent role in the equation. If you look at numbers at, like, let's say the REN 21 report, the investment is in the renewable energy is being done. That is almost 3 times the investment that is being done in fossil fuels. This shows the shift that is happening, but definitely both can and will work together on the short and long term.
Well, that wraps up our discussion for today. Thank you all for your participation, and I hope you enjoyed being part of this insightful panel. A big thank you to our viewers who have tuned in from around the world. We will be back tomorrow with day 2 of Power Week 2021, where we will explore the future of gas in the region's energy transition. That will be our first panel. Then our second panel will be embracing hydrogen to accelerate clean energy. Your attendee link for day 2 will be emailed to you later today. So thank you very much and see you tomorrow. Thank you.
Thank you very much, Bassett.
Thank you, guys.
Thank
Bye-bye.
you.
Thank you.